Hello, the historian here. Well, it's time to talk about something you probably have been waiting for, space combat. So to get this out of the way, starfighters or carriers, they're so small that any weapon they can use would be incredibly weak, so they'd be useless against anything other than a fighter. The weapons fighters carry would also be so short range that they have gained range of the ship's point defense cannons to actually hit with any amount of force. But the point defense cannons would shred fighters to pieces immediately. Oh, if you don't know what point defense cannon is, they're basically fast-firing guns, usually rotary cannons. They're used to take up missiles, so insta-shot fighters, basically. Not for how the ships actually get there. Faster than light travel, although faster than light is often shorted to FTL, which I'll do here. At first, it started as something called hyperdrives, allowed for FTL travel on hyperlanes to an adjacent system or black hole or something like that. Although hyperlanes can go farther than that, including to a different galaxy, hyperlanes are usually natural, but can be artificial in some cases. Then warp drives were developed, which are insane compared to hyperdrives. With a warp drive, you can, warp anywhere within range. The range is determined in a weird way, where a ship can warp to a celestial body within a certain range, then within the range of that body, and repeat that for as far as you have power to warp. You can think of it as chaining warps, but all in one warp. Hyperdrives are less complicated and less power hungry than warp drives, but a lot more restricted to where the drive can move. Another thing is that if you warp somewhere too close, the ship can get torn apart with debris in both the area the ship was warping to and warping from. Well, if enemy ships can warp anywhere, then what's stopping them from warping directly to a major enemy industrial plant or something? A little thing called interdiction fields. Interdiction fields prevent anything outside the field from warping into it, but it doesn't stop hyperdrives. Warping is also not permitted if you are in the field. Natural interdiction fields can form, but you can't rely on those, so there's something called interdiction spires. Interdiction spires are large structures built in orbit of a celestial body, turning its gravitational field, at where you can orbit, into an interdiction field. So they can choose if a ship could go there or not. Interdiction spires are usually built above stars, so all the system has the field, but sometimes they're built above planets or something else small if they're important enough. Hyperdrives are often used to get to a system with interdiction spire for capturing the spire. From there, they can move more ally forces into the system. There is a second method to render the enemy interdiction field useless. Well, mostly. Make a smaller interdiction field in an enemy one. So, as a smaller interdiction field and a bigger one overrides the bigger one where the smaller one is. No one knows how interdiction fields work, but it does work well in this situation. Now, non-FTL travel. Ships have engines in the front and the back to accelerate and decelerate easily, as in space, there's no drag from there being no air, so anything moving will keep moving until it slows itself down with an engine, or it hits something. There are also engines dotted around the ship's surface so they can turn. The main engines of the ships are commonly direct fusion drives, or DFDs. DFDs use helium-3 and deuterium, an isotope of hydrogen, as a high-heat plasma containing a magnetic containment field to achieve fusion, where the ions produced are then, using electromagnets, launched out to provide thrust. Energy can also be derived from the DFDs, which is often used to maintain the reaction in the drive. DFDs produce a lot of thrust compared to its weight, high variability in the thrust, high fuel efficiency, and low amounts of radiation produced. DFDs are highly effective, but they produce a lot of heat. There are systems to get rid of the heat of the thrust. These systems usually only dissipate the heat up to half the engine's maximum thrust. So when you exceed that, heat goes elsewhere in the ship. So making the thrusters burn over where the systems will get rid of heat is only used when absolutely necessary. There's even a name for it when you do this, which is overclocking. The smaller engines all around the ship's surface are often some type of chemical rocket, which type of chemical rocket varies depending on the ship's owner, and the ship's manufacturer. Notice how these ships are powered. Ships are powered with fusion reactors, not too dissimilar to DFDs, but the ions aren't launched out. Most of the time, the heat from the reaction is used to heat up a liquid that is boiled into its vapor form and sent through a turbine to spin it, and a vapor is collected then cooled to be vaporized again. The rotational motion from the turbine is set along the shaft to a generator to, well, generate power. Fusion reactors generate a lot of power, but ships often need to have two for redundancy in case one fails, and to generate extra power if needed for very high-intensity combats. There are also ships that have more for various reasons, such as to power a giant railgun. Power is also often charged up in some form of energy storage to be used later for the same reasons as a second reactor, but cheaper. There are two ways to store energy in this case: capacitors and batteries. Capacitors can gain and release their energy far faster than batteries, but can store far less energy than batteries, to the point that conductors hold the charge of a lower density battery a tenth of their size. Conductors consist of two plates of a material that can conduct electricity with a vacuum, as in a space with no matter, or a dielectric material between them. Dielectric materials are a material that in the presence of electricity causes dielectric polarism, which forces positive charge towards it and negative charge away from it. The charge is held between the plates as one gains a positive charge and the other a negative charge. Batteries are two plates with an electrolyte between them. One plate gains a positive charge, the anode, and the other one gains a negative charge, the cathode, with the negative from the cathode flowing to the anode through a wire to power something. And batteries of your time, the electrolyte is usually a gel. By the time of the First Group War, all batteries have solid electrolytes. The advantages of solid-state batteries are higher energy density, avoiding using toxic or flammable materials, faster charging, and faster flow of the current. Okay, so how the ships can survive a few hits. Armor and shields. Armor is the physical hull of the ship with metal plates to protect it, although they don't always use their strongest metal, as often it is dense and thus will make accelerating and decelerating much harder due to the extra mass. There is also a special alloy of steel developed called regenerative steel alloy, or RSA, that does regenerate, but it's not often used because it's weak to impacts. The way to protect themselves is with energy shields, which protects the ship from, well, high energy particles or photons from outside of the shield, and it regenerates if it hasn't taken a high amount of damage for about 20 minutes or so, depending on the shield. Shields also protect against background radiation, which does damage the shields, but the shields in most cases can regenerate many times faster than background radiation could ever diminish it, along with damage not being enough to prevent it from regenerating. Although ships often do have other means of radiation shielding just in case shields go down. Now for the weapons, at least for now. There are two broad types of weapons: kinetic and energy. Kinetic weapons are physical projectiles that ignore shields and directly damage armor, while energy weapons are things like particle cannons and lasers that are stopped by shields, but when they break the shields, they do heavy damage to armor, and energy weapon projectiles often move at the speed of light or very close to it, making them practically impossible to dodge unless you're at incredibly long distances, where you would probably miss most of the times anyways. There are two main types of kinetic weapons: coil guns and rail guns, which both use electromagnets to propel projectiles. Coil guns consist of a series of wire coils, although they're tricky to make work. You need to be precise which coil you power, as if you power one that's too close to the projectile, it moves the coil too fast and gets stuck. If you power one at the projectile, it just gets stuck. And if you power one behind the projectile, it gets pulled back and gets stuck at the coil. There are two main ways one can get the coils powered correctly. The first one is having a timer built in, which can fail if the projectile is moving too slow or too fast. Or you can have sensors to track the projectile, so a computer can power the correct one. However, there is a major plus: the projectile hovers at the center of the coil, so there is no drag or damage to the gun from the projectile being in contact with the barrel of the gun, as it is actually not in contact with it. Railguns are simpler. There are two parallel rails with the projectile or something holding the projectile being in contact with both rails, which are then powered, sending the projectile forward due to electromagnetism. Compared to coil guns, simple. However, the projectiles have to be in contact with rails to go forward, so it causes drag and wear just down the rails. The rails also get damaged from electricity going between the rails. However, the rails are either made from an incredibly resistant material or with the previously mentioned regenerative steel alloy, so regenerate from the wear for firing, so the rails don't have to replace as much. Lasers are the first of the energy weapons. There are two main types, chemical lasers and electric lasers. Lasers bounce photons between two mirrors through a material that produces more photons identical to the original. This type of material is called a gain medium, with one of the mirrors being partially transparent to release photons. And electrical lasers, they use a gain medium that isn't used up, although they require more power to run, so it can be difficult sometimes to power them. All ships usually have a ton of power due to fusion reactors. Chemical lasers use a field to create the photons that are then duplicated in the gain medium as well as that gain medium, so they are very powerful. But you can run out of the fuel, so it won't work anymore. There are multiple types of firing a laser can do: continuous, long pulse, and short pulse. Continuous lasers slowly melt the surface of the target, so they're not used in combat, but they are often used in manufacturing to cut away at material. Short pulse lasers do the same as continuous lasers. Long pulse lasers are much more deadly. They transfer heat to the surrounding material, form cracks in the material, damage the surface surrounding the impact, and send shockwaves throughout the material. Due to this, long pulse lasers are the most common type of laser used in combat. A single laser generator can also feed into multiple turrets, so a laser can be split up to multiple smaller beams, or one big one. Particle cannons are the big brother of lasers. They involve firing ionized atoms or charged subatomic particles at high speeds using particle accelerators, which accelerates them using electromagnetism. The accelerators can either be a line or a loop. The line sends them down the line once, and that's it, while the loop can cycle the particles multiple times, building up speed until firing. But if you use electrons in a loop, a bunch of X-rays will be produced, and you need much stronger magnets for it to work. The particles most used are electrons or protons, as their small size makes it easy to accelerate, and their charge makes them actually possible to accelerate. However, once fired, the nature of the same charged particles makes it so they repulse each other, making it so the farther away they go, the more spread out they are, so the less damage the beam does. There are a few ways this can be solved. The first is firing electrons, although you can use any charged particle, but the electron's tiny mass makes it easier to accelerate at ultra-relativistic speeds, or 99.9% the speed of light, or more. Particle cannons that do this with electrons are called UREBs, or ultra-relativistic electron beams. They make it so particles move so fast, it makes it so the particles experience time much more slowly, so they spread out much slower than in comparison to our time. Although a strong enough magnetic field will stop a UREB beam. However, the magnetic field would have to be extremely strong, so it's not really a limitation. The second solution isn't stopped by any magnetic field, however. This solution is putting neutral particles into a beam after accelerating it, so the beam is neutral, making the particles not spread out. But the beam can't be accelerated after the neutral particles are put in, so it's very important to do it after accelerating the beam. If an electron or proton beam hits armor, then it produces a lot of X-rays and gamma rays, power, which will heavily irradiate the inside of a ship if it doesn't have radiation shielding. However, most armor is designed to break it instead of producing X-rays and gamma rays, as it would only affect the area of the ship and not harm the crew or computers elsewhere, which is often seen as a good trade-off. Okay, that's it for weapons. Now for the all-important radiators. Radiators are the only way to get rid of heat in space, so they're very important, especially since a lot of systems are very hot, such as the fusion reactors and direct fusion drives. The radiators work by pumping a coolant, using water, through a pipe between the turret systems and external fin or some other similar shape. The external fin has lines of pipes throughout, which is the actual radiator. The hot water is pumped into the radiators to have the heat radiated, while the water is pumped to the internals of the ship to absorb the heat. There is a little thing. The radiator area compared to the rest of the ship grows faster than the ship's size due to the square cube law. The square cube law is where the internals of a 3D shape will grow much faster than the surface area the bigger the shape gets. This is one of the reasons as to why giant ships aren't too prevalent. There are a few solutions to radiating more heat. Make bigger radiators or have more radiators. Bigger radiators are promising, but most of the time that just isn't as useful as the radiators will be easier to hit, so they'll be more likely to be taken out. And if that happens, you can't cool anything at all. Due to that, a mix of bigger and more radiators often used to get the best of both. Another more common practice is to have multiple radiators cool one area, so if one is taken out, the area is still cooled, just slightly less cooled. Time for how ships know where each other are. Sensors. There are two types of sensors, active and passive. Active sensors send something out to detect, while passive sensors look for something. Active scanners work at half light speed as the light has to go out, then come back, while passive act full light speed as it just needs to get to you. And active scanners can also be tracked, but active is useful for locking onto and tracking targets. The most common type of active sensor are phased array radars. Phased array radars are multiple antennas in a hexagonal pattern. Some only have one transmitter, called a passive phased array, while others have a transmitter for each of the antennas, called an active phased array. The second one is far more common in military uses. The active phased array are capable of focusing all the transmission to a single point to go through most of scancers. These points can go in random patterns quickly to find an opponent while being difficult to track. The other active scanner used are LiDARs. LiDARs use weak power lasers as basically a radar while producing a high quality 3D image of what you scanned, so you can easily identify the ship you scanned and find weak points such as radiators. The most useful passive sensors are infrared sensors, which pick up infrared or heat, such as heat from engines or radiators. Really the only other passive sensor there is used are those to detect the wavelengths of light from active sensors. Okay. All ships tend to have some form of supercomputer on board. This is for a good reason. Calculating a lot fast. These supercomputers are in charge of controlling the ship while the captain gives orders to it, so the computer has a lot to handle. Engine thrust, reactor heat rating rate, speed and direction of other ships, aiming weapons, and probably more. It sounds risky to put so much in the hands of a computer, but the programs on them are made to specifically not be self-aware, and computers can do these tasks far faster and far more accurately than any non-synthetic sentient being. Yes, synthetic sentient beings are a thing here. So any ship ran autonomously will outperform any ship with similar capabilities that aren't autonomous just by superior positioning and increased accuracy. Many of the mechanisms on the ship are also automatic, but there's still a crew to fix things and run mechanisms that are being repaired. Now how ships communicate. Ships have large antennas, like the modified one I have from the Tip 6 Begamot pattern super battleship that I use to transmit DSC or time, that work with fast-moving light particles known as tachyon. Tachyon particles rarely exist in nature, but they've been observed when black holes explode, when neutron stars collide, or when stars explode, all some of the most violent occurrences in nature. Anyways, tachyon travels across the galaxy near instantaneously in about 0.25 seconds when measured, so about 3 quintillion 154 quadrillion times the speed of light, if my math is right. So light lag has been basically eliminated, except for extreme distances. This allowed for speedy communications, even in the same distances of the Informer script. Across longer distances, message has to be rerouted through many stations, or so-called tachyon nodes, just to make sure it actually arrives at the right place. This is used in ships in combat to communicate with each other, ship's captains, the fleet's admiral, or to link data between the ships for further outmaneuvering enemy ships, which is useful. Getting close to the end, but it's time for stealth. While there's no cloaking technology, stealth isn't impossible. Stealth ships have various ways to avoid detection. The first one is having engines that burn colder to make it harder to detect, although colder engines are less effective than the more commonly used DFDs, so they often have both, so they have more effective engines when not in stealth. Second way is to use radiators that radiate heat slower. While this could cause heat issues, it does also prevent detection. To prevent heat issues, these ships also sometimes have less effective but colder systems. The third way is to use their engines as little as possible to give the enemy as few chances as possible to detect them. The fourth way is to have the outer layer of the armor be made of material that absorbs light, not just from visible light, but also other lower energy wavelengths, the electromagnetic spectrum, so the active scanners won't be able to detect them as well. Now, fifth and finally is to have a very angular ship used to reflect the light that isn't absorbed in a direction that the enemy ship isn't, so active scanners will have a harder time detecting them. To finish off, time to nerd about freaking doors. It's interesting, I swear. First off, there's just the swinging doors, as the actual door needs to go somewhere, and swinging doors just swings into the room. All doors are also act as airlocks, so if a compartment loses its air to space, the door will prevent the other compartments from losing air. The heavy doors also prevent fire, dangerous chemicals, and flooding from spreading. The flooding is especially important, as the flooding would probably be from coolant to or from the radiators, meaning it could be extremely hot, especially if the ship uses pressurized water, which can remain liquid well beyond its boiling point. It's also often standard procedure that whenever someone goes through a door, they close it, as depressurizing could happen at any time, so having the doors closed whenever no one's going through one is a good way to minimize the compartments that are depressurized. Two more pluses of swing doors is that they're easier to seal, and if you unseal one while you're in an airless room going to a room with air, the door will pop open, which will let you know the room you're going into has air.
Well, it's time for a little note from me, the creator. So I hope you enjoyed it. If you watched up to here and liked it, then please consider subscribing if you're on YouTube or following if you're on Spotify, leaving a like or sharing the video slash episode with other people, as it helps with the algorithm so more people will see this video slash episode. Next time will be the United Nations against the Lingrifor and Salvetti in the first battle of Perpamontes. Also, one last little note, thanks to Spacedock, since their whole realistic spacecraft design really shaped how these ships work, because I want to have realism in this setting, except for when it'd be cooler if it wasn't realistic or for story reasons and stuff like that. But yeah, thanks to them, I'll link their channel in the description of both the Spotify episode and YouTube video, if I remember. If I did not remember, please let me know.